Hello, guys. How are you doing? Here we are continuing with our series on implicit differentiation. Okay, we want to explore how you would differentiate y squared. So, how would you differentiate y squared with respect to x? Well, before we answer this question, let's just leave a space and think about this down here. Let's imagine we had some function and it was, say, 3x squared plus 2x, all raised to the power of 2. Now, here we can apply chain rule, where we use this idea of an inner function and an outer function, okay? So by taking the outside function, something to the power of 2, if you were to treat that as like x to the power of 2, well, that would differentiate to 2 lots of the thing you have, reduce the power by 1, then you would multiply by the differential of the inside function, like this. Okay? And that would simplify to 2 lots of 3 times x squared plus 2x. And then the differential of 3x squared plus 2x is going to be 6x plus 2. So I won't go much further. Hopefully, at this stage, we get the gist that that's how you would use the chain rule. Okay? Whatever method of chain rule you'll use, you should get some answer that's equivalent to this. Now, we can apply the same logic to finding the differential of y squared. So our outside function is something to the power of 2. So differentiating our outside function, that gives us 2 lots of that thing, and then we reduce the power. Then we need to multiply by the differential of the inside function, which in this case is y. And from my previous video, you will have seen that that would be just dy dx. The differential of y with respect to x is going to be dy dx. So y squared differentiated with respect to x is going to be 2y dy dx. Let's take another example just to be sure. Let's take this example. D dx, so the differential of 3y cubed. So we've got the outside function. If we differentiate the outside function, that's going to give us 9, because 3 times 3, bringing the power down, y squared. Then we multiply by the differential of the inside function. Okay, and that's going to give us 9y squared dy dx. And let's just take another example just to be sure. Let's take d dx of 2y squared plus y cubed. So first bit is going to be differentiate the outside function. That becomes 4y to the power of 1 times the differential of the inside function, which is the y, plus 3y squared multiplied by the differential of the inside function. Okay, and that's going to equal 4y dy dx plus 3y squared dy dx. Okay, hopefully this is giving us a feel for using the chain rule to differentiate higher powers of y. And I will see you in the next video. Oh.